At 6 weeks old, a human embryo is barely 13 millimeters long. It is roughly the size of a coffee bean, and right now it looks entirely alien. But inside this tiny, translucent frame, a high-stakes structural event is already underway. The embryo is attempting to build the foundation of the human skeleton. When external forces interfere with this specific stage of development, the consequences are immediate and severe. Medical terminology defines these structural failures clearly. Meromelia refers to the partial absence of a limb, while amelia is the complete failure to form. In the 1950s and 60s, thalidomide caused a global wave of these conditions. These chemical compounds targeted the limbs with surgical precision. Week 6 represents a pivot point in that sequence. Over these 7 days, the embryo transitions from a rough biological sketch to the definitive outline of the human form. To see how a drug could cause such specific destruction, we have to reverse engineer the biological blueprint of how an arm and a leg are actually built. Rewinding to weeks 4 and 5, the sides of the embryo, the lateral body wall, are just starting to change. Small limb buds appear. They are a growing mass of connective tissue called mesenchyme, pushing outward, encased in the ectoderm. The biological engine sits at the tip, the apical ectodermal ridge, or AER. It signals the mesenchyme cells to multiply, physically expanding the tissue. As the tip pushes forward, it leaves behind differentiated tissue. The mass left closest to the body will become the upper arm or the thigh, while the growing tip continues extending outward. This creates a point of failure. The entire process relies on continuous, uninterrupted signaling from the AER. If that signal is disrupted, all outward limb development immediately stops. By week 6, the pace of this developmental growth accelerates. Arms develop ahead of legs. On the upper limb, a flat hand plate forms. Inside, 5 dense ridges appear, the digital rays, the foundation of the fingers. The lower limbs lag behind, forming a simple footplate, but toe rays are not yet visible. Further up the limbs, the buds begin to show regional bending, giving the first anatomical hints of where the elbow and knee joints will develop. Despite these complex shapes, there is no actual bone present in week 6. Instead, the embryo builds a cartilage model. Soft hyaline cartilage is laid down as a temporary scaffold, exactly where bones will eventually ossify. Week 6 is entirely about drafting the soft architectural blueprint. It is not yet building the hard structure of the skeleton. This cellular timeline maps directly to the clinical conditions observed in the macro-level human form. If a teratogen destroys the AER command center early in week 6, the outward push of the limb bud ceases. This is the biological origin of amelia. If the tissue separating the digital rays inside the handplate fails to differentiate, the fingers remain fused together, a condition known as syndactyly. And if the digital rays form an extra ridge during this window, the result is polydactyly, or the presence of an extra digit. These specific failures are what defined the thalidomide tragedy. The drug perfectly intersected with this 7-day phase of AER and digital ray formation. Week 6 is more than a passing milestone. It is a fleeting window where specialized cellular communication dictates the recognizable architecture of the human form forever.